Hello everyone, welcome to my video about Introduction to Propositional Logic. As you can see on my screen, I have some strange symbols here. So now I'm going to explain what they mean, and we will complete these tables to know how to determine if sentence is true or false, because this is exactly what it is about, to determine, to find out if it is true or not. But before that, I want to give you some explanation of basic terms. So what are these basic terms? For example, everybody should know what is a proposition. Proposition is a statement or a sentence about which we can say if it is true or false. That's the meaning of proposition in logic, and that's why we say, never mind, I want to tell you that number one means true. Yeah, we should know that number one represents true, truth. It stands for true, and number 0 stands for false. So that will be very important because we will be using these numbers in our exercises. We should also know what is atomic statement. Atomic statement, and we should know what is compound statement. Atomic statement is a very basic statement which we cannot be broken into smaller parts. So for example, we can say that today is Monday. This is atomic statement. When we say today is Monday, we can say maybe it's true. If it's Monday, if it is really Monday, then it is true. But if it's Thursday or Friday, it is false. So atomic statement is this kind of statement which is not connected with other statements. It is very basic. And atomic statement can be represented by a letter. For example, we can say P. Today is Monday, or the cat is on the table, can be represented as letter P or Q or S, R, and so on. So this small letter of the Latin or English alphabet can represent atomic statement. But compound statement is connection of two sentences, usually with a conjunction. So for example, we could say today is Monday, and is the connector, and tomorrow is Tuesday. So we have two sentences connected in one with the help of conjunction and this is not atomic statement, this is compound statement. And compound statement or connectives, compound statement created with the help of connectives, we should also know what are connectives, is a subject of propositional logic. We need to calculate and determine if it is true or not. That's what we'll be doing later in the video. So let's focus on connectives. What are connectives? If I move back, you can see that we use these symbols to indicate connectives. So the first symbol is and, circumflex. In my other books, it is you can use asterisk sign or and written by using words and letters of the alphabet, but the most common is probably this one. So this is the first connective, is called conjunction. We can write it here, conjunction. The second one is disjunction. You connect it with this character. This is disjunction. Looks like letter V, small letter V, disjunction. Okay. Disjunction number 3 is, actually it should be number 1, is negation. This is negation. I write it here. Tilde sign, or like that, is used to express negation, and soon I'm going to fill them out so you will know what it is about. So this is negation. The number 4 is implication, right? We can call it implication or simply conditional statement. It is conditional statement, so we need if and then. Looks like I don't have enough space here. I need to enlarge it. Implication. And the last one with double arrow, not this is only single arrow. The last one is if with double F. It has double arrow. It's called equivalence, material equivalence. Okay, so we know the name. We have conjunction, disjunction, implication, equivalence, and negation. So let's start with negation. So P is an example of a sentence, right? So here it won't be P and Q, it will be P. We can write tilde P. So we have P is true. This is P is not true. So if P is number 1 P is true. For example, today is Monday. So if we say today is not Monday, we give it value of 0. Insert rows below. Yeah, that's what I wanted. So if we say today is not Monday, then we give value 0. So if we negate or question this value, then it should be 1. And this is the solution of this table of negation. P, it is true that P, it is not true that P. Okay, so this is the simplest one, which is called negation, indicated with the symbol of tilde. This is called connective. We have actually it's not connective. It's atomic statement because we have two same letters, P and P, but this is not true. So this is not connective yet, but this is propositional logic describing different value. But the first connective, actually real connective, will be conjunction, which is connected with the symbol and. So we need to have two statements. See, so that's why it is compound statement. It's not atomic statement because we have two different values, P and Q. Here we had only two same letters. So for example, today is Monday, today is not Monday. But here we can say today is Monday and today is Tuesday. Which doesn't make sense if we connect two different values, so it has to be different, right? Not the same. So number 1, here we write number 1, 1, 1, 0, 0, 1, 0, 0. And what it means? It represents true or false. So we can say today is Monday. P can mean today is Monday. Q can mean tomorrow is Tuesday. So how can we combine this sentence? We can say P and Q. So here we need to write P and Q. Okay, and we already have this compound statement. So if we say today is Monday and tomorrow is Tuesday, if both of them are true, then compound statement will be always true. We can say today is Monday and tomorrow is Wednesday. That will be of course false. In this case will be also false, and the last one will be also false. So conjunction is only true. It is only true if two parts are true. If it is logical. Here you can see the cat is on the table and dog is on the floor. The cat is on the table and dog is not on the floor. No, it's not possible. So remember that conjunction is true in only one case, if both elements are true. Number 2 is disjunction. We're using or connective, so we write it like that: P or Q. In that case, yeah, let's copy that because it's actually the same. This one remains the same, but we need to determine the truth. We're finding if it's true or not. So this is yeah, we should highlight it in a different color, but I need a fill color. Let's make it green. I think green color is okay. Okay, so P or Q. So here it will be obviously false. No, it will be true. It will be true. That one will be true, true, and only one case will be false. So as you can see, as conjunction is true in only one case, disjunction is false in one case. So you can say today is Monday or today is Tuesday. Or today is Tuesday or today is Monday. Why is that? Because it's called alternative. This is called alternative as well. Disjunction or alternative, because we have two options. Either one of them is true. So you can think about any statement you want. Think about statement you have and compare it. Yeah. You choose two options. In alternative, you choose two options. You can say the water is hot or water is cold. Either two options is correct. So if one is false, it is still true. But if two are false, for example, let's say that the truth is that water is hot. But if you say the water is cold or water is a little warm, if both of them are not true, then it will never be true. So at least one of them has to be true in order the statement to make sense and provide true information. Number 3 is called implication or conditional statement, and we use it notation of arrow to indicate it. Like that, P, Q. If P, then Q. If P, then Q. And implication is also false only in one case. When? In this case, when from the truth. When the truth implies false. It's not possible. Truth never implies false. All other cases are true. Because false implies false. Okay, so in this only one case. If false implies true, then it's also correct. Here again, the last one is called equivalence. If and only if. This is if cat is black, then cat is blue. Right, but here cat is blue if and only if cat is black. Right, that's how we can understand equivalence. And we will use double arrow, so we will use P, Q. Okay, here. So now we have the right symbol for equivalence. And equivalence is true if both of the elements, both of these parts of the statements have the same logical value. So if it's 2 times 1 or 2 times 0, then it's true. Other cases, of course, false. So equivalence, remember, 2 of the elements of the proposition have the same logical value, either 1 or 0. Okay, so that's all what you need to determine the logical value of these connectives. And this can be used in more compound statements. That's how we do it in studies, and I will show you example of a calculation we do. Let's do an exercise, and this will be helpful for us to solve this exercise. Okay, I have them here. Okay, then we have an example here. Check the logical value of this formula. If, this is from Polish, I'm translating, of course, because I found that some nice exercise in Polish, and I will translate it to English. So the atomic formula are given on the right side. P stands for false, Q stands for false, R stands for false, S stands for true. So we will substitute these values for this statement here, and we will find out if the statement is true or false. Okay, let's make it a little bit bigger. Here, so this is our statement, compound statement. Look, you have so many elements. So what do we have? How can we break it into? We have conjunction. No, actually they are separated with brackets. The first one is implication, conjunction, another implication, implication, and implication. So we have how many connectives? 1, 2, 3, 4, 5 connectives. And we need to find out which one is true. So if you want to, we need to treat this statement or proposition as whole. So we need to break it into smaller parts. You need to know, in order to know the value, logical value of the whole sentence, we need to break it into smaller parts. So we need to calculate each of these connectives separately. So you could write these tables many times, but this is time consuming to write the table many times. So what I suggest, like, let's give some space here. Right? If you give it a space, you can assign the value into it. Okay? So think about it. We have P and Q. We have P and Q, not and. P, if P then Q. If P then Q. P stands for 0, Q stands for 0. So we have 2 times 0. And what do you remember from implication? If it's 2 times 0, it is true. So next to it, we can write number 1, that this statement, the first one, is true. How about the next one? We have R stands for 0, S stands for true, number 1. Again, what do you remember? If the first part is false and the next one is true, then the whole statement is true. So next to this statement, we also write number 1 to confirm that this is true. So we have 2 true statements, okay? And this one on the other side is another implication. We have P. P stands for 0, S stands for true, 0 and 1 for implication also make a true statement, okay? So we determined these 3 parts, 1, 2, 3. 3 of them are true. But now we need to treat these 2 separately. Let's give it different color. And let's give this statement different color. Because you need to know the order. Do it in the right order. So, because they have brackets. So now we know that we have conjunction, and. This means and. So we have, we can say P and Q. So if P is true and Q is true, what does it mean? If both elements of conjunction are true, the whole statement is true. So we can say, what can we insert here? One moment. What can we insert here? Let's insert brackets. Symbol. I want to insert a symbol. Shapes like this. Okay. Like this. And now I have to rotate it. Oh, I'm not rotating it quite well. I didn't see it properly. Okay, let's just stretch it, make it shorter. Later it'll be easy, I will just copy and paste it, you know, guys. Okay, I've got it. Okay, so we can see the bracket here. So if this one on the left is true and the other one on the left is true, and we connect them as conjunction using and, it means that obviously the whole statement is also true. So these 2 elements are true. And now you need to check these 2 elements, part 1 and part 2, and that will be implication. So you have implication of 2 elements. This one is copy and paste. I will insert it here again. Let's make it a little longer. So what do you see here? We check value of this green one with the yellow one, the whole one. The whole yellow one is number 1, and this green one here is also number 1. So what is the you see that you have arrow. So you have conjunction, not conjunction, you have implication, if statement, conditional statement of truth with another truth. So two truth for implication, what does it mean? It means also truth. So basically we know that this first statement, the entire statement here is true. So the value of this total, this whole complex or compound proposition is true, right? That we've done this one. And if you want to know the answers, we have rozwiązania, answer. Of course, exercise 2 is true. So we've done it correctly. That was exercise 2. So this first statement is correct. So I encourage you to pause the video, and you can do others and determine if they are true or not. So you can use the same method as I did. Instead of writing tables many times, just break it into smaller parts, break it into atomic statements, and use connectives to determine which of them are true or not. Follow the rules of conjunction, disjunction, implication, and equivalence to get it done correctly. There are many more exercises. There's predicate, calculus, there are calculation of sets. I can make another video about it, but that was a very basic one. Maybe we can do another one, okay? If we have a little bit of time, we can do something like that here. As you can see, 0.5 maybe a little bit more difficult. Let me enlarge it. Yeah, it's too big. It's too big. So this is our statement, but we need to know the values. What does P, Q, and R stand for? All of them are true. Okay, so we know the number 5 of all of them have number 1, so I don't need to write them down here. So how will you bite into it? How will you bite into this? You see you have tilde sign means negation. You have even double negation between brackets. So how can we determine the value? First of all, what we will do, we'll break it into part. We have conjunction of two true elements. Q and R are true. So conjunction of two true elements is 1. So we know that the first element here is number 1, right? We have equivalence of two truth elements. P is true, Q is true, so of course this is also true, but as you remember, the two elements of equivalence, if and only if they have the same value, either two zeros or either two ones, this is true. So this element is true, this one is also true. And here we have implication, but first let's bite into this double negation. So if you have one negation, this becomes 0. Okay, so now it's 0, but you have another one here. So it is not true that not true means true. So all the statement here is true. That one remains true. So we have implication of two true elements. So we have if today is Monday, tomorrow is Tuesday, and this is true sentence. All the value of this sentence is also true. That was example number 5. Let me check if I did it correctly. Yeah, exercise 2, example 5. Where is it? 5, they say it's false. So let's see, where did we make a mistake? All of them are true. P, Q, and R are true, right? Just to make it, P, Q, and R are true. P, Q, and R, all three elements are true. Let me determine it again. Q and I see you guys. See, guys, what is the problem here? Because we have a square bracket. So this mustn't be treated. This mustn't be treated as part of this expression. This is before square brackets, and the whole expression, as you can see, the whole expression here is in square brackets. And we put tilde sound, which means it is not true, before square brackets. So before the whole statement, right? And that's what matters. That's why all the statement which we calculated in square bracket was true, but it becomes false, because negation is written before square brackets. So as you can see, we have Q and R is true, so we have, actually this one becomes 0, because we have negation. We have negation of this Q and R, so this statement which is green becomes 0, this one remains 1. And then we have implication 0 and 1. So if 0 and 1 create true, so the whole statement is true, but we have negation before the square brackets, that's why the whole statement is false. So be careful about these brackets. Square brackets are more important than just parentheses, normal brackets, because this was negation of the entire statement. Okay, I hope that you learned something from me today, and give it thumbs up if you like it, and subscribe to my channel. I'll create more videos in the future. Thank you, and see you next time.